Hello everyone, I'm Xiao Gang. Okay, let's write the login and registration interface. Let's write the login interface first, because login is relatively simpler. Okay, the normal development process is that we usually have the server's interface first. The interface we talk about in a broad sense refers to the method you use, such as HTTP or WebSocket on the network. We all call them interfaces. In a narrow sense, interfaces refer to this kind of inheritance in our inheritance system, and interfaces inherited with a colon. Actually, no matter how you call it, as long as you know its structure and context, you know what this interface refers to. So here we define a user struct. We are not connecting to a database here. So we write this information in our memory. You can connect to a database or use other local methods to save it. Both are fine. This struct is called yaogang, simple user info. This struct is only used on the server side. Because this struct is our internal data, so we put it in the server type section. So we call it simple server user info. Then this struct needs a few fields. We won't write this constructor function. It's a bit troublesome. The first one is definitely username. We'll give it a long. Then there's also a password. We'll give it a password. We'll call it password. For the password, we'll also give it a long. Then there are also some for because we often need to store this phone number. Okay, next is our email address. Email is more practical than the phone number because sending phone numbers, you have to buy SMS services from carriers. That service often gets spammed. Then there's a problem. You also need to do the timing. That is, only one verification code can be sent every 60 seconds. Actually, this verification code is very simple. You request a verification code from the server. We randomly generate one for it, then send it to everyone via email. And of course, this will include several sets of courses. We explain them separately. You can just assemble them when the time comes, because we write each function as a plugin. You just need to assemble them in the project. We'll give it all to long. Okay, so this is the your info information we are using. Okay, then we can actually make it more complex. That is, we can override some operators and such. I didn't write it that way here. No intersense. Let's use ID. Actually, sometimes we don't use this intersense too. Because what if you say my service volume? The whole country uses mine. Then you use intersense too. Then it might go live. Right. And you might not just have use ID. You might have one ID. HID has student information. ID card information. When it comes to IDs, sometimes we consider, in the case of a massive number of IDs, we might not use integers. But for convenience, we just write it this way. So with this user inference in our tearaway object, we do init data here. We should use a piece of data to store our current user data information. So here we are simulating. We put one here. What would be more appropriate to place here? Let's place a tearaway. And this struct is right here. We won't consider performance for now. The performance-oriented one is called URList. Inside this URList, in the init data, we first initialize a mock1. Actually, this part should read from a table. This URList, we need to add a default amount of money. Add default gateway force. And then here, we get the reference of the first one we added. Let's call it URI info. Okay, we only need to add one. Then we set its URID to 1. Of course, you can set some custom IDs here. And also default username, verification, etc. We won't bother with those. You can check out our previous tutorial series for this. That series covers a lot of database knowledge, such as how we handle transactions and so on. Then for this password, we need to use MD5. If MD will hash history. That's fine. We need to encrypt this. The password is 124D45556 because we don't want our account information to be transmitted in plain text over the network. So we will encrypt the password. As for the phone number, let's keep it simple. 123456792。 As for the email, let's keep it simple too. Email. Let's use 10023@tcoco.com. Okay, this way we have some initialization data. Now in C++, we definitely need to process this HTTP request. Then we will do the dispatching here. After all the data comes in, we will mainly handle it here. So we really need to add a new enum here. And we happen to have this login enum here. We'll just paste it over. Okay, we'll paste it over. Here, we just handle the login. Okay, the break here needs to be written. Okay, then here we need to handle this case. Here, this is for registration. We'll put the order in place, even though we wrote it in reverse order. In terms of growth, registration should come first. Pay attention to this break. Now that we have this, we need to write another method similar to this one. For this method, it's obvious that we just praise it like this. We'll write it out together later. Okay. The one is for handling registration. One is for handle A. They both pass in this data. Okay. We mainly handle the login one. So how should we handle the login? First, we definitely need to register this struct. So we obviously need to, in the request type, define the struct. Because when we log in, it actually, right? The most core information is actually has a username and password. So I'll write it step by step for everyone. Write it step by step and put it here. Let's paste it over first. So obviously it needs to inherit from our database. Because why do we need to inherit from the database? You can see it's because in the database there is such a unified method. We hope this method can be reused. So we make it inherit from database. Because this definitely needs to be validated, then this is what we mentioned earlier. Use spec body. And at the same time, we write the specific properties inside. So obviously, it is EERAMTAMTFOR Then we also write the constructor along the way. Okay. Good. After writing it like this, then we need to implement this method here because we must verify whether this data is usable. Then this login server responds. It is actually this. If unavailable, it will return exactly the reason for the unavailability. We first need to check the username. Then if it is obvious if this username is an invalid username, we return this invalid username. If it is an invalid password, we return this invalid password. Right, then how? And this is verification. Did it pass? We consider it passed. First of all, then for the verification here, it must be verified based on this string. Because this verification will definitely be used in many places. When you register and consume, you will use. So we need to put this code into this 0U2. Then coming to the 0U2, we start writing the code inside. Then we use a struct to write it. We did not use this namespace. Okay, let's just note a semicolon. No problem. Then we make it public. Let's define the rules. Our rule is that the username must be 6 to 18 characters. Only digits and letters are allowed. The password must be 6 to 18 characters. Only digits and letters allowed. And the phone number must be 11 digits. The email must only contain digits. Okay, so how should we write this? Then we need to break this down as well. So let's write the lowest level first. That is, we check whether this character is valid and whether this character is purely numeric. Okay, let's first write these two underlying interfaces. Okay, so how should we implement these two interfaces? Actually, what we pass out is an F stream, right? If this stream is 0, we consider it invalid. Then how do we determine this here? Actually, we have many ways to determine it here. We can use Unreal's regular expression. You can just search for it directly in Unreal. But the reason we don't use it here is because it's a standalone program. Unreal's regular expressions are not implemented. So here, we need to replace it with AC 加加加 DIPMP Chen. I'll paste it over here, and then I'll explain it to you. How is this implementation achieved? First, we iterate through it. We iterate through each of its frame. Then we directly call the methods in this C++ library. And there are these methods. This is a regular expression. I place this regular expression here because it cannot be used in a standalone program. This is a regular expression. We will skip over it. Everyone can take a look. And here, because the corresponding header file is not included, we just need to include this header file. Then this method uses the C++ approach. One character, y is alpha. Is this it, char, or is it number? If it's either char or number, this means it passes. Then go ahead and check the next one. Run. Then if it is neither char nor number, it means this one didn't pass. We'll just consider it invalid, right? So if all of them pass, then we consider this character valid. So how do we determine if it's purely numeric? Well, for purely numeric, it's actually relatively simpler. So it's the same. First, let's determine whether its string contains a substring. Then we just need to check the B number, whether it is a number. Then we return a true. So these are all wide characters because UE5 uses wide characters. Okay, so these two are our underlying interfaces. And for convenience, we are encapsulating the upper level interfaces here. That is to check the UALM and password. So how should we handle this UALM and password? It's very simple. We just need to call our underlying interfaces. That is, first check whether the character length meets the requirement, then simultaneously check if it contains this illegal character. If it has illegal characters, it means it didn't pass. Right? Then the password is actually the same. We'll write it like this here. You might be wondering, why write it this way? Because it's like this. If you are on the client side, actually, when you check this password, it hasn't been processed. Yes. It's because of this. Because on your client side, what we access is 1, 2, 3, 4, 5, 5, 6. But on the server side, it actually needs to go through an MD5 hash process. So this is how it is determined here. Then this processing. After this is done, we check whether it contains any illegal characters. That's the situation. So here it is, determined through this macro. It is in the standalone program. Is in this standalone program or in this client plugin. Of course, writing it this way is definitely not ideal. You can use other macros to determine it. That's fine too, because in our project architecture, this file, it is either in this ng, either there is no such button inside. So writing it this way is fine, okay? Then let's come back. Since we've already written this part, let's also write the rest for everyone. That is, we check this for in numbers. Actually, we didn't write a very complex validation check here, because this is mainly for internal use. As for number, 4 is actually quite simple. Just check if this number is 11 digits. And then check if it's purely numeric. This email is a bit more complicated. You should write a regular expression for it. You can search online. There are many. We just need to check here whether it has a circle, whether it has a, and then check that it is not empty. Then that should be fine. Yeah, basically just a rough check. Meaning it must have a circle and a dot, and not be empty. Then for the rest, you can write whatever you want. So this part is done. After finishing this, go back to our place here. Back here, didn't we just have this thing called processing? Let me take a look. handle it within the type. Jump like this, it should be in the request right here. Here we are. This is our data. This request data is the data in our network communication, and this data is specific to our server. This user list data, these two things are different. Don't mix them up. So in this case, how do we determine whether this thing is usable or not? So actually you just need to check if it satisfies these two. Because the data in your request only has the username and DAM, and here just use this. Then, if both of these pass, we consider this validation to be passed, proving that this data is valid. Okay, so after having such an interface, after having such a structure and processing like this, we go back to our seller object to handle this login request. So let's first prepare a I'll paste it over for everyone. We prepare such a response. We need to handle this response. The type of this response equals, let's check, enum should be here. We paste it in. We need to set it equal to login response because it returns a login environment. Then we need to wait. We need to prepare a login struct. Now we need to read this data from our JSON. So first we deserialize it back, load this JSON data into it. If the parsing is not successful, then we need to handle it at this point. We will use this. For this result, we will directly give it a failed to parse client request data. Then just throw this response out. If this data is unavailable, then it proves that this data is invalid. It might not have been sent from our client. It might have been sent directly using some DDoS tool. After they know your protocol, they attack you. Then after we check, this data is invalid. Then we also return it back. So this invalid one, note this case. What is passed here? Is this reference? So this invalid reference, is it the username that is invalid or the password that is invalid? If it passes here, it will become a success. Then at this point, we continue moving downward. So at this point, the verification has passed. Now we actually need to find this data. So we prepare a login response data. We don't have this data yet. Wait. So let's write it. This login response data. Okay. This data as the response data. As for this response data, it's for login. I'll paste it over here. Actually, the login data we return is also very simple. Note the semicolon here. It actually returns a username. That is, you pass this username and its user ID. Because we will use this user ID. Right. Okay. It seems the capital where here is a bit off. I won't change it. It would be too much effort to fix. It doesn't really affect readability. Let's just ignore it. Alright. With this data ready, we need to construct it. So here, we first need to check its password, whether the account, username, and password are correct. If it is correct, only then will we proceed with this further processing. If it is not correct, we will not perform this processing. Okay. Then we need an interface to verify its password. Right, so let's implement this interface again. Let's switch back, okay? Let's put it below. This interface is to check whether the username and password you passed in are valid. If the username and password you passed in are both valid, then it will return the UID to you. Otherwise, and if it fails, it will also return the failure reason to you. We need a response type. Let's check where this type is located. This place returns a struct. It's the data we need to use. Actually, it's this. It's this data. Okay, then let's implement it. This part is a bit tricky, but it should be fine. So at this point, we just need to loop through and iterate over this data. We'll just use A, use T, although we won't modify it, so we can add a const in front. Then we iterate over this data. This URRRRANCNY, we modify the TMP every, not him. Okay. By default, we all return FLS. Then if this outUIGF should be the default, then here we do it like this. That is, if this temp equivalent forwards iUser is not URALM equals this URLM, we are case insensitive for this F data, and at the same time this password equals the incoming password. Okay, then the username and password are both equal. We just return to it directly. Sometimes we also need this UID. So here we need to output this UID. For example, we can just copy it here. Okay, let's take a look at this. The error here is because this is passed to the F event. This U-boot actually provides a... For this, we need F data. Let's see if we can directly click to data. Unfortunately, there is no to data option. Then we use F data. Just use forint. Because it is a basic numeric type. Through this method, we will know whether the verification is successful. Then if the verification is successful, if he uses us, please ask elsewhere. We need to verify the username and password. If the verification is successful, we can copy the URLM because this proves that the URLM is correct. We can take this. The SP part needs to be distinguished. This is SP, this is R1Q. That is the request data. This is the data we need to return. Then we will take the returned. Because the return data you write in through this function area, modify it. Now we only need to take the UALM of this function, copy it over to everyone. After processing the requested data here, copy it to the return data. Then finally, we just need to return this response. Here we return the response to this point. Then you will find that this response is not actually linked to our data yet. Actually, the reason is this, because a line of code is missing here. Because you can look at the data structure of this response. It mainly contains the request type, response type, and this data. Obviously, we still need to... So this is the specific data we have loaded into it. Then we also need to verify the values inside. So how do we verify it? Actually, we need to handle it here. So for the handling here, we copy this down. This same verification result, we need to process. The processing method is relatively simple. We need to be here. If it succeeds, the B here. If we succeed, it should be here. Here, we will do some copying. Set BJX to true. Then this part here, data is not needed. We can handle data outside because data is an F stream. We need to fill in user lam and user third. Okay, then we need to write the type of this response. The type of this response is actual type. Its type is this. It is a low-class pipe, and the result of its response is actually correct without type actually equals. There are quite a few types for this type. We can see it should be success. We just need to return a success for it. Okay, so here we actually need to return again. That is, if we don't find it. Then we need to repeat. Let's make it a login repeat. However, here it's result type. We need to change it. Here we need to see what types it has. Here it might be no such username or password, incorrect username or password. We cannot tell if the user exists. We can only tell you the username or password is wrong, but we ourselves know whether it exists or not. Okay, this person knows, just copy this, type over. Alright, then we return this boss. Okay, so actually our server-side interface is relatively well prepared now. Okay, this part is mainly for verification. Only after passing do we need to serialize this login data and send it over. Actually, if it doesn't pass, the serialized data is just a bunch of useless data. Only through this data is it passed here. It's just a user ID, right? Then the username. Okay, then this dispose calls back upward. Where is it called? It is called here. You see, we haven't called it yet. It might be here. So here, let's call it, because we've already written the framework. Actually, we already have this interface. Let's compile it. We'll write the client result for everyone shortly. Okay, there are many compilation errors here, right? Let's check. This error says it cannot find this. Let's see, it cannot find this type. We probably didn't include this error type. Let's include it. Okay, let's compile it. We still have compilation errors, right? Let's check. This place must return a value. If all the previous conditions are met here, we just pulled a bunch together in one place. Okay, let's take a look. Let's take another look. There shouldn't be any issue. Good. In this way, a backward server interface for us is basically already written. This lesson has been going on for a while. Let's stop here. Thank you, everyone.